Good day, my name is Kubash Chigelski, and I will be talking about or introducing you to linear factor models. First, what we need to talk about is why are we looking at linear factor models? So some background. Well, when you are watching the news at 8 o'clock, what you see is, or what you might be told on the BBC, is the FTSE 100. It goes up a few points or it declines a few points. So it's gone up a few points or it's declined a few points. And this is represented in percentage terms. First of all, what is the FTSE 100 or the FTSE in general? It is an aggregate market index that tells you how the British stock market is performing. So it's a measure, an aggregate, a market aggregate for the British stock market. Next, why is it that this aggregate is going up and down? Well, the reason why it is going up and down is because there's information that is emerging, and that information is then being interpreted by investors, and it's telling them about how the market is likely to perform in the future because of how this news is going to impact the economy. So, for example, we are told that COVID-19 infections go down. Well, what does this mean? This is positive news, likely for investors. So what happens? The FTSE 100 increases. In other words, the level goes up, so that is a positive change, a return. Another example is that there's an announcement that COVID-19 infections are going up. So how will investors interpret this? Well, it is likely that the FTSE 100 will decline in response. In other words, investors see this as bad news and hence the market reacts negatively. There is a negative return, a negative change on this index. Another example is there's some more positive news relating to a new vaccine that is extremely effective. So this is a hypothetical situation. Again, investors are likely to view this as a positive. And what is it that happens? Well, the market responds positively. In other words, the FTSE moves up and down, and so do all other markets across the world, which are also represented by their own market aggregates, in response to news entering the market and investors interpreting this news. Now, it is not only a market aggregate that is impacted. So it's not only the general level of the stock market that is impacted. It is also individual stocks. For example, for a pharmaceutical company, they're impacted by news, or an airline company, they're impacted by news, such as that relating to travel restrictions. Additionally, also individual sectors, industrial sectors, such as the airline or transportation sector or the e-commerce sector might be impacted by specific news relating to the general state of the economy or general news such as a conflict breaking out or another pandemic breaking out somewhere in the world. The idea is that this news has to enter the market somehow, and we need to quantify how this news impacts the market. And this is where factor models come into play. And this is what we will be doing in this lecture, or in this topic, in this specific presentation. We'll be discussing theoretically how can we quantify the impact of different news on the market. So this is what we'll be looking at. And we can quantify this news relatively precisely, or the impact of this news relatively precisely, by using so-called factor models, by estimating factor models. So what are linear factor models from a theoretical perspective? Well, what they are is they are models that relate return behavior, in other words, the changes in stock prices and index level, to a set or a single explanatory variable. So in other words, we relate the change in, let's say, the FTSE 100 to some variable, and we'll explore what these variables can be and why we choose these certain variables. So essentially what they are is they are a representation of the so-called return generating process, where the return generating process is the process that causes changes in stock prices and changes in index levels. Okay, where the indices, stock market indices, are aggregates of all the stocks or a number of the stocks that are listed on a stock exchange. So this is what factor models do. They allow us to arrive at a representation of this process that is driving stock prices. The first such representation is a so-called diagonal model. This was proposed by Sharpe in 1963, and it is considered to be a precursor to the so-called market model and also the capital asset pricing model, which is an asset pricing model which relates returns to a measure of risk. So what does the original representation of such a model look like? Well, first of all, what we have is returns on the left-hand side. In other words, the change in the level of market index or the change in the price of a given stock. And then what we relate it to is a specific index, a single index. This could be the level of the GDP, let's say. It could also be the level of interest rates or specific changes in the interest rates or changes in GDP. Why? Because interest rates impact stock prices, they impact stock markets. These could be, or the index could be any so-called macroeconomic indicator which investors are likely to react to. Going a little bit further, it can be any piece of information that can be measured that investors may or may not react to. The model also allows us to test whether information that we hypothesize is important for markets is indeed important. And then A and B are so-called model parameters, where what we worry about is the B, which later then becomes the beta, is the sensitivity of returns to a change in our explanatory variable, whatever that may be. In other words, what the diagonal model proposes is that returns respond to a variable. Initially, that variable was not identified, although Sharpe proposed that it is a single factor or a single variable that is most important in influencing stock markets and returns that we should be worried about. Although it was not directly identified, Sharpe did mention that GDP, in other words, the gross domestic product, a representation of the state of the economy, or a market index, could be used to explain the behavior of stock prices. So this was the original early formulation of this concept that we can relate returns to specific variables which move stock markets. There is a central assumption that underlies the diagonal model, and that is that whatever variable that we use captures all systematic or common information. Where we define systematic or common information or variables as such, those that influence the entire market. So we don't worry about something that is specific to a firm. What we worry, or is specific to a given stock, what we worried about is common information that will impact the entire stock market. And the reason why we worry about so-called common variables or common factors that move stock prices is because we assume that we can hold a number of stocks. And by holding a number of stocks, we can diversify away the individual events that impact the stock price for an individual stock. In other words, we can engage in something that we call diversification. We diversify away the information or news that impacts only a single firm, and we only focus on information that impacts the entire market. However, following Sharpe's 1963 paper, King in 1966 proposed that the behavior of returns on the US stock market is described by more than one factor. In other words, this is contrary to what Sharpe proposed. Sharpe proposed that we should look at one very important explanatory variable. Instead, King proposes that there are multiple or additional variables that we should consider. In other words, there isn't only one source of information that moves stock prices and the entire stock market. There are various sources of information as reflected by various indicators that move stock markets. The one limitation at this point was that these variables were not identified as of yet. However, they would be reflected in a so-called residual term, which was represented by C subscript I in the original formulation of the model. So, as a response to his criticism of the diagonal model, that the diagonal model is concerned only with one variable, Ross formalized and introduced something called the arbitrage pricing theory. And the central concept or tenet of the arbitrage pricing theory is that there are multiple variables that move stock prices and the stock market. So although King suggests this, it is Ross that formalized this concept. In other words, in summary, the APT hypothesizes that returns are described by multiple factors, and we view this as a response to criticisms of single index models and the so-called capital asset pricing model. Thus, how is it that we formally describe the arbitrage pricing theory? And specifically, what we are interested in is the so-called multi-factor linear factor model. Now, why are we again talking about this? Well, because we are formalizing a description of the behavior of stock markets. Specifically, we relate the changes in this model, changes which are so-called realized returns on a given stock, asset, or a market index, to a set of explanatory variables, which we call factors. In other words, a multitude of variables represented by this term that impact the behavior on the stock market as represented by changes which are called returns on assets. And the exposure of returns to each so-called factor is quantified by the so-called beta, this term here. So, hence what we have is a relationship between returns, the behavior of assets, in other words, to a so-called set of factors that are hypothesized to drive these changes. And this linear factor model, this formalization refers to the behavior of assets over a period of time as new information enters the market. So this is a so-called time series model, right? A model that describes the behavior for a single series over a given period of time in response to information emerging over time. At this point, we do not specify still what these factors are. We simply remain within this realm or within this idea or paradigm that we are dealing with so-called systematic factors. Factors that do not only impact a single index, a single stock, but impact the entire stock market. So that is what we are worried about. We are worried about factors that are systematic and common to all assets that comprise a given stock market. And then what happens is we have the second part of the arbitrage pricing theory. So again, the arbitrage pricing theory proposes the idea that there are multiple factors or multiple sources of news or variables that drive stock returns. And the first model, the so-called linear factor model, which we'll be focusing on, proposes that there are a set of variables that impact the return on a given asset over time. The second equation of the arbitrage pricing theory proposes a cross-sectional relationship. So we are no longer worried about one asset and observing it over time. We are now worried about multiple assets, multiple stocks in one single period of time. So the so-called APT pricing relation is a cross-sectional model. We want to see how numerous assets respond to the sensitivity to a specific factor in the linear factor model. So hence what we do is we estimate the so-called risk premium, which is the compensation for exposure to a certain factor for a given asset. So in other words, we estimate the linear factor model for a multitude of assets, and then, so those are the linear factor models, that's time series, and then we take our so-called expected returns, which let's define that as the average return on an asset over a sample period, and then we relate it to that exposure for that specific asset that we estimated the linear factor models for. So hence, the linear factor model, model 1, is a time series model. In summary, it relates changes in returns in stock prices to innovations in factors over time. Whereas the arbitrage pricing theory is a cross-sectional model. It relates returns to exposures to factors that feature in the linear factor model. It establishes how returns vary with a given level of risk, where the betas now, the exposures to variables in our multi-factor model, are the so-called measures of systematic risk for each asset in our sample. And then what we say is that factors are associated with a significant risk premium are those that explain returns in so-called equilibrium. Now, it is important to realize that the ABT, the arbitrage pricing theory, is a framework. Again, a framework conceptualizes this idea that asset prices respond to multiple sources of information, not a single source of information as proposed by the diagonal model. The linear factor model and the APT model, so this is the linear factor model and this is the APT model, are linked. We would estimate the linear factor model for a number of assets over time. So for example, we take stock A and then we run a so-called regression, which is a statistical technique that is used to estimate the model. And we do this for, let's say, 100 different stocks. And for each of these, we obtain betas. And these betas are associated with the variables that we input into the models. And this will be demonstrated using articles further. Then what we would do is we would estimate a second model. So it depends what we are interested in. The second model takes the average of returns for each asset and then relates them to the exposures that are estimated in the linear factor model. So hence the betas in the linear factor model are then the data in the cross-sectional APT relation. So this is important. And hence, in order to arrive at the second equation, we need to be able to correctly state this model. State this model, in other words, specify it, means that we need to be able to accurately, or as accurately as possible, construct a representation of the linear factor model. If this is not the case, we then cannot arrive at the arbitrage pricing theory model, the so-called APT model. Now, what we are essentially seeing is the basis. What this theory is, it's the basis of the theory relating financial market behavior to the macroeconomic environment. And frankly, any other variables, not only they are macroeconomic in nature, such as COVID, but ultimately measures of COVID are macroeconomic variables because they impact the macroeconomic environment. So it is the basis for relating financial market behavior to the macroeconomic environment or any other variables that have a systematic impact. So please remember this addition to this statement. So constructing the linear factor model in its purest form allows us to study the impact of the macroeconomic environment and any other variables that impact the macroeconomic environment and their impact specifically on financial markets. So let's talk about the development of the arbitrage pricing theory and specifically the formalization of this idea that it is multiple sources of information that move stock markets. How did this come about? Well, we start with so-called early work. So what did early work do? It focused on testing the proposition that one, there are multiple variables or multiple sources of information that feature in the linear factor model. In other words, multiple sources of information that move stock markets. And two, that there are multiple variables or the exposure to multiple variables that is priced in the arbitrage pricing model. So for example, what Roll and Ross did is, so these are some early authors that, well, they was the second to introduce or discuss the arbitrage pricing theory and formalize it after Ross proposed in 1976. What they did is they used statistical techniques to show that there are 5 factors in the return generating process. In other words, that the US stock market responds to 5 factors. They didn't identify these factors. They used so-called statistical series, and then they found that at least one is priced in the cross-sectional APT model. Then we have Krzyzanowski and Toe, who replicated or conducted a similar study, not only on the NYSE, which will represent the United States, but also on the Toronto Stock Exchange. So he extended the study of multi-factor processes to Canada. And what he found, or what they found, sorry, was that there are 10 factors or 10 variables, although factors beyond the 5th were not that important. Again, they used statistical techniques, so they did not have specific information such as inflation or, let's say, GDP or industrial production that would impact the market. They had statistical representations. The literature of the field was not yet sufficiently developed. Then what we have is we have Hughes, who also repeated the study or conducted a similar study in Canada and found that there are 5 factors, in other words, 5 representations of the influences that move the stock market in Canada. And then we had Alton Gruber, who showed there are 4 factors that impact markets in Japan. So the idea of these early studies was a proof that indeed multiple markets respond to more than one single factor, where these factors represent different forms of influences. So we can't only look at one source of information, we need to look at multiple sources of information. And this applies across markets. So the general early consensus was that there are multiple factors that describe the return generating process, that describe the behavior of stock prices, although the evidence on the number of so-called priced factors, factors that matter in the APT relation, in other words, equation 2, is somewhat limited. And that was shown by Alton and Gruber in 1988. They found that a single factor is priced, and also Beanstalk and Chan. So in summary, where is it that we are at? Well, it has been accepted that multiple factors feature in the linear factor models. In other words, there's multiple sources of information that move markets, and that multiple factors are priced, although there is some, or was some, debate on this. This was back in the 80s. So what you're seeing here is a genesis of the evolution of this framework. However, so far we've spoken about factors. What exactly are these factors? Factors, specifically APT terminology, refers to variables. Right? Variables, something that changes over time, that can take on a different value. One of the first early criticisms of the APT framework, this formalization of this idea that there's multiple sources of information that matter for markets, is that, well, we don't know what these so-called variables are. Early techniques use so-called statistical factor models. Okay, so they used factor analysis in order to derive statistical representations of these sources of information. So they would derive something called principal components or factor analysis to extract statistical factors. In other words, numbers of series or series of numbers. Sorry, the other way around, series of numbers that would represent these forces that move stock markets. The problem was that these were statistical representations of these forces. They would not be really specific as to what it is that they represent. What they would achieve is a confirmation of multi-factor character of the arbitrage pricing theory. In other words, what we saw here, a confirmation of this idea that there are multiple sources of information that we need to worry about that move stock markets and stock prices in general. So how do we move from this idea of using the statistical analysis to represent so-called variables which would not have a meaning? Well, this is the point of departure. So what we have here are criticisms of these statistical factor models. The question that arises is, what are these pervasive factors? Without knowing what these variables are, because we are only representing them statistically, all that we can do is say, well, there's multiple variables, but it is difficult to determine how the arbitrage pricing theory is then useful for predictive and explanatory purposes. For example, at this point, we could say, well, we suspect that COVID-19 moves markets. But at this point in time, we wouldn't use measures of COVID-19. We can interpret a measure of COVID-19 such as deaths, let's say. But at this point in time, which is now the early 90s and the early 80s and late 80s, when there's a realization, well, what do we do with this model? We did not have the framework being sufficiently, or the framework wasn't sufficiently developed to say, well, now we can use specific variables and we can relate the behavior of markets to these specific variables, which could be inflation, measures of COVID-19, although this is obviously a very recent topic, but I'm using it as an example as it is very topical. So hence, estimated betas in the model, the so-called parameters, would not have an interpretation beyond that of significance and representing that idea or confirming that idea that there's multiple drivers of stock markets. So hence, early studies used statistical factors that had no direct interpretation. So what did early work and development do then? Well, a number of authors then said, well, why don't we try use so-called macroeconomic variables? So this was a response to this criticism of, well, we can represent the influences of, or that impact stock markets and individual shares using statistical factors. And instead, what we will now do is we will use pre-specified factors, so-called macroeconomic variables. Macroeconomic variables, well, these are variables that are representative of the state of the economy. So, for example, inflation, interest rates, industrial production, unemployment, number of retail sales, and so on, also oil prices, metal prices. All of these variables capture or represent some aspect of macroeconomic activity or economic activity in general. And the idea of these uses, or the idea of using macroeconomic factors, was first expounded by Chen, Roll, and Ross in 1986, who published a seminal paper. And what they mention, or what they state, what they noted as a problem with early APT work was this embarrassing gap that would exist between the theoretical exclusive importance of so-called systematic variables, state variables, and the ignorance of the identity. So now the identity of these variables would be represented using macroeconomic variables, which can be interpreted. And Chenrow and Ross suggested specific macroeconomic variables that could be used to represent the behavior or explain the behavior of stock markets. They suggested that these variables are, number one, industrial production, two, changes in risk premiums, the term structure of interest rates, changes in expected inflation, and unanticipated inflation. And this would explain the cross-section of returns, which meant that they also had to be significant in the so-called linear factor model. So what is noteworthy about this step of the development of this framework is that Chen, Roll, and Ross's work presents a departure from the use of identified factors and presents the use of macroeconomic factors that can be interpreted and understood. Then the literature proceeded, or the field proceeded, to develop so-called fundamental factor models. And in this instance, unlike the other two classes of models where we use macroeconomic factors or statistical factors. These models suggest that we can explain the behavior of assets by relating them to specific accounting variables, which we call so-called fundamental factors. These are, for example, the dividend yield, the book-to-market ratio, and the size of a firm. And these would be cross-sectional models. There's debate whether this is truly an APT type model. Okay, we will be focusing in these topics on the basis of, on the APT framework, or at least we'll be applying the principles of the APT framework. So it's important to note that if we use accounting variables, the question then arises, are these indeed congruent with the so-called arbitrage pricing theory? It is worth knowing that these variables can be used. However, they are not like statistical factors, which represent common influences or systematic influences, and macroeconomic factors, which are direct proxies for these macroeconomic or for these systematic influences. So the problem then with fundamental factor models is that they do not use systematic influences. Instead, they use firm-specific attributes. So again, we consider multiple firm attributes. That's how it's congruent with the arbitrage pricing theory. But on the other hand, these are not systematic in nature, and hence why there is this debate. But in summary, what we need to be aware of is that this theory, or this idea that markets respond to multiple sources of information, is presented by the arbitrage pricing theory. And this is what we'll be focusing on. We'll be focusing on specifically the linear factor model, this idea of what is it that impacts stock markets and how do we represent this impact. In other words, our focus is more so on the macroeconomic linear factor model, the use of macroeconomic variables to describe the behavior of markets. So what is it that we'll be doing? We'll be gaining an insight into the exposure to macroeconomic events. So this is what this framework allows us to do. It will allow us to explain the behavior of financial markets, and we will do this using directly observable data, and we will also discuss how it is that we can select factors, and we will do this through reference to the literature. The benefit of these models, as you will hopefully come to see, is that they are easy to understand and they allow us to debate or begin a debate as what is it that matters for markets, stock markets. We will be covering a study in our exercise session in order to give you some insight into early versions of the model. This is an easy article. It is an article by Barry, Burmeister, and McElroy, written in 1988. And this is part of the exercise that will be uploaded, and this is what will be discussed during our exercise session.